Good morning, students. Today we're going to be going over lesson 3.1, parts 1 and 2, and this is on inequalities. So let me share my screen with you. Okay, so I want to talk about what an inequality is. An inequality is a mathematical sentence that demonstrates that two numbers are not equal. Let me say it again, a mathematical sentence that demonstrates that two numbers are not equal. Okay. Let's take a look at some examples here. Now I want to contrast this with the idea of an equation. An equation tells you what x is, or whatever variable that you're using. For example, in this solution here we have x equals 7. So we can say that with confidence that x is 7. But an inequality, in contrast, tells you what x is not. Okay? So here I have the solution to an inequality. X is not 7. And we can say with surety that it is not 7. Now, why learn about inequalities? There are situations when you do have numbers that need to be compared to each other. Now, I know we did a lot of comparison with ratios of numbers, comparing them with division. But an inequality is kind of like, not so much like a ratio, but it's when you actually have different values that may be put into a formula that show that two different numbers or different sets of numbers are not equal. Okay. Now, the thing with inequalities is most of what you know how to do with inequalities, you have learned by doing equations. Okay. But let's just go over. So I want to go over the different symbols for inequality. This one is called greater than. This one is called less than. Now, a lot of times people get these symbols mixed up. Like, what do you call it? They look the same, except they're just facing different ways. Hint, they are read from left to right. Okay? Meaning that whatever is on the left of the symbol has to be greater than what's on the right in case of greater than. What is ever on the right, the left of less than here has to be smaller than whatever's on the right of it. Okay, so if you get confused in what to call them, then the idea is just compare your inequalities from left to right. Now, this was taught to me as like a second grader, so this may sound a little silly, but just a way to remember, if you're not sure which one means greater, the one that is facing open, my second grade teacher taught me that this represents an alligator's mouth. If an alligator's hungry and it's going to eat something else, it's going to eat something that's big. Okay, so the bigger thing is the one that the open side is facing to. She also taught me that the small side, or the one that's facing, the point, is like a witch's nose, and the witch is making fun of a very small child and pointing at it saying, look how small you are, look how small you are. Now I know that that sounds very corny and very childlike, but keep in mind I'm 51 years old, and that was taught to me when I was like 7 or 8, and for some reason I just can't seem to forget it. So whatever Mrs. Vaughn, my second grade teacher, was doing, she did it right, because I have not forgotten that. Either way, the open side, or the wide side, is facing the larger thing. The pointy side is facing the smaller thing. Okay, let's continue with the symbols. The next one is called greater than or equal to. So you have the bottom half of an equal sign, and on the top half you have the greater than sign. The next one is less than or equal to. Same thing, you have a less than sign on top and the bottom half of an equal sign on bottom. The fifth one is the not equal sign. Basically just write an equal sign and put a diagonal slash through it. And the last one is about equal, which is sort of like a curvy equal sign. Now, about equal is often used, and we actually did use it in some lessons already, where you have a number that um, is going to be some sort of long decimal, like, for example, an irrational number. And in a case like that, when you have an irrational number, it just makes more sense to write it as very close to it because you can't continually write every digit of the irrational number. Okay? So basically, about equal is really not used so much in inequality lessons. It's used to say that to write the exact number may take too long or may be impossible. So therefore, we're going to write an estimated number. Okay, so this implies estimation. Now, the other ones do not imply estimation. Okay, this is simply saying two things are not equal to each other. Okay, um, and these different variations in less than or greater than um, just basically tell you that something is either smaller or larger, or that there is some variance that it could be smaller or equal to, larger or equal to. Okay, I hope that that makes sense. Now, continuing on with the lesson, I have designated these inequalities as two broad types. Greater than or less than, I call them open inequalities. Okay, and greater than or equal to or less than or equal to, I have called closed inequalities. Now, I use those names on purpose. We're going to talk in just a little bit about graphing in the lesson. So this is, by the way, 3-1 part 1, and then in the same video we're going to go ahead and do part 2. Part 2 we'll talk about graphing, and those designations will help you a little bit more. Okay, but anyways, so in an open inequality, it can be used on numbers or variables. On a closed inequality, it's generally only used with variables. Now, it can be used with numbers, but it makes an awkward statement with a constant meaning a number. So let me just give you an example. 3 is less than or equal to 7. Okay, now we know that 3 is definitely less than 7. Okay, now this is not a trick question like, well, 3 elephants and 7 mice. There's nothing like that. We're just simply talking about the numbers, not the things that those numbers could represent, or values like there's something way more or less, anything like that. Okay, so taking any trickery out of the question, basically we're just talking about the numbers. Now, the statement here is true. 3 is less than or equal to 7. Okay, but since 3 is a constant, then that means that it has a fixed value. 3 is never going to be 4. It's never going to be 2. Okay, it's never going to be 3.5. It's only going to be 3. So technically, the second part of the statement, or equal to, is unnecessary. Okay, now this is true. I'm not saying anything that's false, but I am saying something that's unnecessary. So the statement with an open inequality, 3 is less than 7, just makes more sense. Okay, so closed inequalities are often used when there is a variable. Now, open inequalities are used with a variable as well. Don't get me wrong, but since a closed inequality can be defined as equal to or something else, there's two definitions here. And the more definitions makes the definition of what we call a closed inequality a little bit stricter, okay? Because there's more that's being said about it, okay? So when there's more details, usually something is stricter. Now, let's go ahead and move down. Now I want to talk about a solution to an inequality. Now we've talked about solutions to equations for quite some time. Now, um, in a later lesson, we'll go over the specific steps of solving an inequality, but I just wanted to talk about the solution to an inequality. Now, obviously, a solution, as you had learned for an equation, is any number that we can say that the variable is equal to, okay? Solution to an inequality is any number that can make a true statement. So inequalities work a little bit differently, okay? So we want to make a true statement, not a false statement. Now, like I said, in the previous lessons in chapter 2, we did discuss the fact that there are sometimes equations that give you an untrue answer, okay? Now, and in that case, it is called a false equation, or basically the idea is that there's no solution. So the implication is an equation is always going to be true. If it is not true, then it's not really considered an equation, is a good way of saying it. Now, mathematically, we would call that an equation that has no solution, okay? But in reality, we would look at that and say, okay, this is just basically false. So moving on, you've probably looked ahead at my example here. If x is less than 7, now here's an inequality statement, then x could be 6, 5, 4, 3, 2, 1, 0, -1, and continued. Okay, now I could go lower. So given that I know that the value of x is less than 7, then any number that is less than 7 can be x. Okay, now if I want to get complicated and add fractional numbers or decimal numbers, like 6.99 is less than 7, well, I can put 6.99 on my list. Okay, the criteria here is that it has to be less than 7. So if you see an inequality statement, then if you put something in that makes it true, then you would have the solution to the inequality. Take, for example, 3 plus x is greater than -4. Okay? Now this looks similar to an equation, but it's an inequality because instead of an equal sign here, we have an inequality sign. So if 3 plus x is greater than -4, then the value of x can be substituted for any number that would make this true. Okay, so let's see. If this is greater than -4, then let's just say I substitute in 1. So 3 plus 1 is greater than -4. So 3 plus 1 is 4. So then I get the statement 4 is greater than -4. That is true, isn't it? Yes, because 4 is 4 above 0, -4 is 4 below 0. Okay? Now, this is a good time to pause if you are following me to take notes. So I'm going to go ahead and pause my video, and then I'll get back to you with part 2. Okay, let's go back to part 2 of the lesson. I had, give me just a second here. I had just reset my paper here. All right, let's talk about graphing inequalities. To graph an inequality, basically all you're doing is you're showing the possible values of what it is on a number line, okay? Now when we think of a graph, the most common graph we think of is a coordinate plane, okay? But when we're graphing an inequality, many times the number line is very useful, especially if the inequality is written in a similar form to an equation, okay? Now, so I've written a couple of number lines here. Now, an open inequality is one that represents an open statement. And for that purpose, we also have what's called an open dot. So the open inequality, x is less than 5. Here's how we would write this. Starting on our number line, you go to the number that is being compared to the variable. Start at 0 and go 1, 2, 3, 4, 5. Either on or over the number line. I prefer over just because it's easier to see whether the dot is open or closed. But you can do it on the line, at least that's how it is in the book. But I prefer over, so if you're asking me, I would say do it over the line. So 5 is the number that's mentioned here. Now what we're looking for is not the value 5, we're looking for the value of x. Okay, so the statement says that x is smaller than 5. So anything that's smaller than 5 would go to the left of 5. So draw an arrow from your open dot showing anything that is to the left of 5 could possibly be x. Now, with a closed inequality, now remember, a closed inequality has the half equal sign at the bottom of it. With a closed inequality, when you graph it, you use a closed dot. So in this one, the statement is x is greater than or equal to 3. In the same sense, the number that is being compared to x in the inequality is the number that you write your dot at. Start at 0 and count up. 1, 2, 3. So I'm going to go ahead and put my dot here at 3. But to show that my statement could equal 3 or be larger than 3, I'm going to put a closed dot here. Okay, so the open dot means that the statement cannot be the number where it's at. It can only be less than that number. But a closed dot means that it could be that number or whatever else the inequality says. Now the inequality here is saying that x is greater than or equal to 3. So I would draw my arrow in the direction of any number that is larger than 3. Okay? Now with the closed statement, simply put, the closed statement says that 3 could be the answer or anything that the rest of the statement says is true, or basically the direction that your arrow is going. With the open dot or the open inequality, the statement is saying that, well, this is the number that we're being compared to. It could be anything less than that number, but it cannot be that number itself, okay? So just want you to keep in mind these different variations here. Now, a lot of times people get stuck and they have a hard time figuring which way is the arrow supposed to go when I make the inequality. I get that I put the dot where the number is, but which way does my arrow go? I'm going to give you just a little hint. If you have your variable on the left and your number or constant on the right, which is the standard way of writing a solution, then your arrow, I'm sorry, I'm giving my thought process here away. Your inequality sign will be facing the same direction as the arrow. You'll notice this is pointing that way. This is pointing that way, okay? The same with the other one is true. My inequality is pointing to the right. This is pointing to the right. Now, on occasion, you're going to get an inequality that could be written in a form like this. 5 is less than x. So basically, it's just not written in standard solution form because the variable is on the right, the inequality is on the left. Be careful, in a case like this, if you were to graph it, then your arrow is going to be facing the opposite way of what the inequality says. Okay, so if that's confusing to you, what you can do is rewrite this statement. But when you rewrite the statement, you have to make sure to flip the inequality sign so that the pointy part is still facing towards the number. Okay, so whatever is facing the number when it's written this way has to be facing the number when you flip the situation here to the standard format. Okay, hope that helps, and thank you very much.